Oak Ridge National Laboratory proved a buried pipe delivers 60-degree air when it is 95 outside. The United States military uses it on bases worldwide. It costs $300, and in most American counties, you're not allowed to build one. Central air conditioning costs $8,000 to $15,000 to install. It dies the instant the grid goes down. The system that replaces it costs $300 in PVC pipe and runs on physics that have not changed in 4 billion years. By the end of this video, you will know the exact trench depth, pipe diameter, length calculation, and radon mitigation method to build a passive cooling system that works when nothing else does. Let me show you exactly what they do not want you building. Welcome back. If you are new here, this is what we do. We find the technologies that were buried. We verify them with named sources, institutional research, and real-world evidence. Then we hand them to you. No speculation, no paranoia. Just documented knowledge that someone decided you were not supposed to have. If that sounds like something worth keeping in your feed, subscribe now, because this channel exists for one reason. When the information matters, you should not have to pay $10,000 or break a law to access it. Today's topic is one of the most thoroughly documented we have ever covered. This technology is older than most countries. 3,000 years ago in Persia, engineers solved a problem we still pretend is unsolvable. They built structures called badgirs, wind catchers. Oh, towers that captured moving air and forced it down through underground channels carved into the earth. The air entered hot. It traveled there through tunnels surrounded by soil that never changes temperature. It emerged cold. No electricity, no refrigerant, no moving parts, just geometry and thermodynamics. These were not primitive experiments. Persian qanats, the underground water and air channels, stretched for miles. Entire cities were cooled by networks of buried passages that exploited the single most reliable thermal mass on the planet, the ground beneath your feet. The Romans figured it out independently. Underground air channels beneath villas and public buildings moved ambient air through the earth and delivered cooled ventilation to occupied spaces. Different empire, different continent, same principle, same result. Now jump forward. 19th century, Lancaster County, Pennsylvania, Holmes County, Ohio. The Amish and Mennonite communities adopted earth tube cooling when they settled in North America. They dug trenches with horse-drawn equipment. They laid pipe with community labor. They built systems for a few $100s that delivered 60-degree air in July. No grid connection, no utility bill, no licensed contractor. Those systems are still running, over a century of continuous operation in some cases. Exposed to every weather extreme Pennsylvania and Ohio can produce, still delivering cooled air, still maintained by hand, still costing essentially nothing to operate. Then came the 1970s. So the energy crisis hit. Oil prices quadrupled. Oh, suddenly, the United States government was very interested in any technology that could reduce energy consumption. The Department of Energy funded research programs. Oak Ridge National Laboratory began thermal performance studies on earth-coupled cooling systems. The University of Nebraska ran field measurements. For the first time, the technology the Amish had been using for a century got a formal scientific investigation. So the science establishment finally studied what the Amish already knew. Here's what they found. Now, before I lay out the full research, I want to mention the vault. Everything in this video is the surface of what we found. The vault is our complete research library. Suppressed energy systems, forgotten food preservation methods, water purification. The grid does not want you to know. Medical knowledge that predates the pharmaceutical model. No fluff, no filler. Just verified research organized by category so you can find what you need when you need it. The link is in the description. But you do not need the vault to build this. Everything you need is in the next 15 minutes. The University of Nebraska conducted field measurements on buried pipe systems in the 1980s. Their finding was precise. 200 feet of 6-inch diameter pipe, buried at optimal depth, delivers air between 60 and 65 degrees Fahrenheit, when the outside ambient temperature is in the mid-90s. That is a 30-degree temperature drop from a pipe in the ground. The mechanism is simple. At a depth of 8 to 10 feet, soil temperature stabilizes between 50 and 55 degrees Fahrenheit, year-round. Summer or winter. It does not matter what the surface temperature is. The Earth at that depth is thermally stable. It has been stable for as long as the Earth has existed. When air passes through a pipe buried in that soil, heat transfers from the warmer air into the cooler surrounding ground. The longer the pipe run, the more heat exchange occurs. Most of the temperature transfer happens in the first 100 feet. The remaining length provides additional conditioning and ensures consistent output. Oak Ridge National Laboratory confirmed these numbers. Their thermal performance studies validated that Earth-coupled systems produce reliable, measurable cooling without any energy input beyond minimal air movement. A single 6-inch pipe run delivers 300 to 500 cubic feet per minute of conditioned air. The German Passive House standard incorporated earth tubes as an approved ventilation preconditioning strategy. The Minergie standard in Switzerland did the same. Thousands of operational earth tube systems exist across Europe right now, built legally, inspected, and approved, performing exactly as the research predicted. Then there is the military. The United States Department of Defense uses earth-coupled cooling systems on installations worldwide. Military facility engineers install them to reduce diesel generator dependency at forward operating bases. This is documented in Department of Defense facility engineering publications. The systems are designed, installed, and maintained by military engineers operating under Federal Construction Authority. Federal Construction Authority. That phrase matters. It means the military is exempt from the local building codes that apply to you. They build the exact same system, in the same soil, using the same materials, under an exemption from the regulations that make it illegal for civilians. So if it works for the military, and it works in Europe, and it works for the Amish, why can you not build one? Follow the money. The United States residential air conditioning market generates approximately $30 billion annually. That is equipment sales, installation labor, refrigerant refills, annual maintenance contracts, and replacement cycles every 15 to 20 years. That is $30 billion a year in recurring revenue. A $300 earth tube requires no electricity, no refrigerant, no annual service contract, and no replacement cycle. You cannot patent a pipe in the ground. The thermodynamic principle is public domain. The materials are commodity, PVC, available at any hardware store. There is no proprietary component, no consumable, no subscription, no margin for anyone except you. Now look at the regulatory architecture. The Environmental Protection Agency regulates radon under 40 CFR Part 192. Radon is a legitimate concern. It is the second leading cause of lung cancer in the United States. But the regulation is written broadly enough to capture earth tube installations, requiring professional radon testing and certification that adds thousands of dollars to a $300 project. The concern is real. The regulatory response is disproportionate. The International Code Council Mechanical Code requires that below-grade ductwork be installed by a licensed HVAC contractor. Here is the part that should make you angry. HVAC industry representatives sit on the ICC code development committees. The industry that sells $15,000 air conditioning systems participates directly in writing the rules that require you to hire them for the $300 alternative. The cost transformation is the key. $300 in materials becomes $5,000 to $10,000 after mandatory contractor labor, professional radon certification, engineered drawings, and permit fees. At that price, it costs the same as the central air system it was supposed to replace. The economic advantage disappears, the industry wins, and then there are the Amish. Same technology. Same counties, same soil, no enforcement. An Amish family in Lancaster County builds an earth tube with community labor and a horse-drawn trencher. Their non-Amish neighbor 3 miles away would face code violations for identical construction. That is not a conspiracy theory. That is a documented enforcement disparity with a specific regulatory explanation. I am being precise here. I am not saying a secret committee met in a dark room. I am saying the regulatory structure produces an outcome that benefits a $30 billion industry, and representatives of that industry participate in creating that regulatory structure. You can draw your own conclusion. What comes next is the actual construction blueprint, the exact dimensions, materials, and procedure. If this is the kind of knowledge you think people should have access to, subscribe and share. This is how it spreads. Before I give you the steps, I owe you the honest limitations. Look, radon is real. This is not negotiable. You must test. Every earth tube installation requires a radon canister test. And if results exceed the EPA action level of 4 picocuries per liter, you need mitigation built into the design. I will show you how. Never use corrugated pipe. Corrugated pipe creates ridges where moisture collects, biofilm grows, and mold colonizes. Smooth wall PVC only. No exceptions. If you live in the southeast or Gulf Coast, humidity is your enemy. A properly functioning earth tube in a high humidity climate can produce several gallons of condensation per day. Your design must account for drainage, or you will create a mold incubator instead of a cooling system. Performance depends on soil type. Or the University of Nebraska data reflects favorable Midwestern soils with good thermal conductivity. Sandy soils underperform. Dense clay performs better. Your results will vary. This is not a drop-in replacement for central air conditioning in every climate and every situation. It is a primary cooling strategy that may need supplemental measures in extreme conditions. And if you are digging a trench deeper than 5 feet, OSHA trench safety applies. Sloping, shoring, or a trench box. A collapsed trench can kill you. Do not skip this. Now that you know what to watch for, here is exactly how to build it. Step 1. Select your route. You need 150 to 200 feet of horizontal run. The trench runs from a shaded area on the north side of your property to your foundation wall. Avoid proximity to septic systems, well lines, and large tree roots. Step 2. Dig the trench, 8 feet deep. This puts you in the stable thermal zone of 50 to 55 degrees Fahrenheit. Maintain a consistent depth throughout the run. Respect OSHA trench safety requirements for any excavation over 5 feet. Step 3. Lay a gravel bed, 4 to 6 inches of clean gravel at the bottom of the trench. This ensures drainage and prevents the pipe from sitting in standing water. Step 4. Install the pipe, 6-inch schedule 40 PVC, solvent welded joints only, no mechanical couplings. Mechanical joints leak. Maintain a 1 to 2% grade slope along the entire run, falling toward the house. This is critical for condensation drainage. Step 5. Install the inlet. The above-ground air intake goes on the shaded north side of your property. Elevate it at least 18 inches above grade. Install a galvanized or stainless steel insect screen. This is where air enters the system. Step 6. Install the condensation drain. At the lowest point of the pipe run, typically where it meets the foundation, install a drain fitting. Condensation must have somewhere to go. Step 7. Seal the foundation penetration. Where the pipe enters your structure, seal it completely, expanding foam and exterior grade caulk. No gaps. This is both an air seal and a radon barrier. Step 8. Install the passive radon vent. At the foundation penetration point, install a T fitting with a vertical pipe, extending at least 12 inches above your roof line. This creates a passive stack effect that vents any radon accumulation before it enters your living space. This is your primary radon mitigation. Step 9. Install airflow assist. A 12-volt DC inline duct fan powered by a single 50-watt solar panel provides active air draw through the system. This fan draws a fraction of the electricity of a single light bulb. It works off-grid with a small battery bank and runs indefinitely on solar. Step 10. Test the system. Run it for 48 to 72 hours. Place a thermometer at the outlet. You should read low 60s when ambient air is in the 90s. Deploy a radon test canister in the room receiving the air. If results are below 4 picocuries per liter, you are clear. Total materials cost, $300. PVC pipe, fittings, solvent cement, gravel, inline fan, solar panel, screening, and a radon test kit. Annual maintenance. Inspect the inlet screen for debris or nesting. Flush the pipe every 2 years with a garden hose. Check the condensation drain for blockages. That is it. That is it. That is the entire system. The Persian engineers knew this 3,000 years ago. The Romans knew it. The Amish have known it since the 19th century. Oak Ridge proved it with institutional research. The University of Nebraska measured it down to the degree. The German Passive House Standard codified it. The United States military builds it on bases worldwide under an exemption from the codes that bind you. And in most of America, you need a $5,000 permission slip to put a pipe in the ground. Every conventional air conditioning system in this country becomes a dead metal box when the grid goes down. The compressor does not run. The refrigerant does not cycle. The thermostat is dark. I have $15,000 of equipment producing exactly zero cooling. The Earth is still 55 degrees. You now have knowledge worth $8,000 to $15,000 in avoided costs. In a grid-down scenario, it is worth considerably more than money. You have the depth, the diameter, the length, the slope, the materials, the radon mitigation, and the maintenance schedule. You have everything. This is the kind of knowledge that does not survive if people do not pass it on. Share this video. Send it to the person you know who is building, who is prepping, who is tired of writing checks to an industry that sells them a system designed to fail when they need it most. Next week, we are covering another technology that was regulated out of residential use despite centuries of proven performance. It involves water, and the industry that killed it is even bigger than HVAC. Make sure you are subscribed. The ground is still cold. Use it.